Hey everybody, I'm Brian Julius. I'm the Chief Content Officer for Enterprise DNA. Welcome to this session of the Enterprise DNA Business Intelligence Summit. Appreciate you joining me today. It's a topic I'm really excited about. Offsets are something I've been using for the past few years, and they have made a huge difference in the way I handle time intelligence within DAX. And I think if you've not seen and used this technique, it really is going to seem like magic to you. And if you are a user of the offset technique and a fan of it like I am, hopefully you'll still pick up some interesting tips and tricks along the way. So let's jump in. And the story today starts with a meme. And it's a meme by my friend Carlos Barboza that he posted a few days ago. And the thing that struck me about this, other than it just being funny, is if you look down here, it got 950 likes. And I don't know what your LinkedIn account is like, but I've never gotten 950 likes on a post before. And so I thought, what is it about this post that resonated? You know, why is everybody crying about DAX? And I think there are 4 reasons why learning DAX is so difficult. I think one is inadequate understanding of context. And as we all know, filter context and row context and context transition is really the key to understanding DAX. And we've had a number of presentations that have dealt with that issue. We've got some more coming. That's not really what I'm going to be talking about today. Nor is the second one, bad data modeling. That there are so many times I see questions on the forum or files that people send to me that say, oh, my DAX isn't working. Why isn't my DAX working? And the answer is because your data model is broken. And that when you've got a bad data model in PowerBI, no amount of DAX knowledge is often going to help that. That model has got to be fixed before the DAX is going to work. The third thing is, I think using DAX too much is using DAX in places where it would be much more appropriate to push the work upstream to Power Query, to SQL, to data warehouse. And so I think oftentimes what I see, particularly with beginners, is them putting too much strain on DAX and using DAX for things that aren't dynamic within the context of a report session and could be much better handled through an upstream process. And so the thing I really wanted to focus on today is what I call here using too much of DAX. That there's a lot of DAX that I think is really extraneous, and that I think, as I'm going to talk about in a few minutes, the Pareto principle really holds with DAX, that 20% of DAX really accounts for at least 80% or more of the benefit. And I think oftentimes people learning DAX focus on that 80% of the functions and the functionality that really doesn't have a lot of impact. And we're gonna delve a lot more into that issue today. And so why in particular am I picking on TI, time intelligence functions? And I guess the first question is, what is time intelligence? And time intelligence is really just any analysis that deals with a temporal aspect. So looking at the movement of a variable through time, looking at comparative years against other years, looking at cumulative impacts over time, moving averages over time. Anything that deals with a temporal aspect is time intelligence. And so it's probably the most common and important category of analysis in Power BI. It's hard to imagine too many reports that I've done that haven't had a time intelligence aspect to them. But the time intelligence functions, just give me a lot of heartburn in the sense that a lot of them are duplicative and overlapping. I think they're confusing. Some of them incorporate endpoints, some of them don't. They oftentimes don't do exactly what you think they would do based on the name. We're going to talk about YeartoDate, which I think is a really good example of a function that doesn't actually do what you think it's going to do. A lot of the functions to me feel kind of inflexible. They kind of do what they do and they're hard to modify. There's a level of inconsistency in them that I think makes them hard to automate. And the biggest thing is really when you look at it in the context of what we're going to examine today, which is the world of offsets, they're really almost wholly unnecessary. And I've put the almost in there because I was talking to Antrish Sharma earlier this week, and he's absolutely expert in the field of optimization in DAX. And when I said, they're wholly unnecessary, he said, well, there are limited circumstances where even when you're using offsets, there's an optimization benefit to the CAN TI function. So we're going to talk a bit about performance, but I'll leave that almost in there as a nod to Antrish. But in my view, they're really almost wholly unnecessary. And we'll talk about why that is and what you do in place of those functions. Before we get to the magic solution, though, I do want to jump out and show you something that I put together with Gustav Dudek and a number of the enterprise DNA experts. And this kind of gets back to the Pareto aspect that we talked about a few minutes ago. And in looking at the Pareto principle, what I did is surveyed half a dozen experts in DAX. It started off with a conversation I had with Greg Deckler, and then expanded to the enterprise DNA expert team. And what we did is we all voted independently as to the functions within DAX that we viewed as kind of must-haves and the ones that really were of lesser value. And then I compared the results, and there was a tremendous amount of consistency in this, that 58% of the functions received no votes from any of the 6 panelists. And if you accrue upward, it was basically 80% received 0, 1, or 2 votes. And in looking at that, what we found is the top 20% of functions were 70 functions. And in looking at those 70 functions, in terms of how they broke down, one of the things that really jumps out is time intelligence. That there are 37 time intelligence functions, and only one of them, DATAD, was cited by the panelists as being in the top 20. And that is interesting to me, in the sense that it's one of the most important aspects of analysis, but the functions themselves were not deemed by experts to be valuable. And the reason was because of this concept of offsets. And so if we go back to the presentation, here's the magic solution with offsets. And it's a very simple concept, which is that you've got a continuous number, that a field that represents a whole number continuous series, and the present period is always 0, and then the next future period gets a 1, the next future period after that a 2, a 3, and a 4, and so on, and the first past period gets a -1, then a -2, and so forth into the past. And the periods can be literally anything. It can be years, quarters, months, days, but then it can get a little less standard. It can be fiscal years, it can be weeks, it can be fiscal weeks, semesters, trimesters. I even made up some zygorgs. You can make up your own period, and we could say a zygorg is 37 days in a year that is divisible evenly by 17, and 16 days in years that are not. And you can make that into an offset series, and you can move backwards and forwards in that non-standard time period. And offsets always work the same way. And that's one of the huge benefits, is that they become very standard, very transparent, very easy to spot, easy to use, because of that consistency of operation. And so what I want to do is I want to jump into Power BI, and I want to talk through some very specific practical examples, things you come across in time intelligence all the time. Previous period, cumulative totals, and that year to date that I talked about, moving averages, net work days, which is a big topic now. It's always been a big issue in terms of looking at the number of business days between a start and an end date. Now, thankfully, DAX has incorporated net work days into the DAX lexicon, but there's an even easier way to do it than that. We're going to talk about non-standard calendars briefly, but the non-standard calendars really just fall into that previous discussion of adaptability to any type of period. Then I want to talk briefly about performance, about how does offsets compare in the speed of measure operation to standard TI functions. And then just talk a little bit about some conclusions and some final thoughts to leave you with. So at this point, what I'd like to do is just jump right into Power BI, and we'll start looking at that previous period. So here we are in Power BI, and I've set up a number of scenarios related to previous period. And this is something that is absolutely critical in time intelligence, is being able to obtain easily the value of the previous period. So whether you're doing a year-over-year analysis or looking at a whole range of analyses that deal with changes over time, being able to go back one period is absolutely critical. But before we do that, I want to jump into the data model, and there's nothing particularly special about this data model. It's something called the Superstore data set. It's a very standard practice data set, not unlike the Contoso data set. But the one thing I want to talk about before we jump in here is this dates table. And we really need to talk about, where do offsets come from? And in this case, where they come from is what we call the Enterprise DNA Extended Dates table. And this is the brainchild of Melissa DeCourte, our resident M guru. And Melissa has put together what I honestly and strongly believe to be the finest date/calendar table in existence. It's free for Enterprise DNA members and non-members alike. And it's available on our forum. We'll post the link to this in the description, the comments section. But you can just search on the forum for extended date table. And Melissa actually just within the last couple of days has posted version 2 of this. So you basically just take this code, copy it, and it's also available for you Enterprise DNA subscribers who work in the Analyst Hub. I've put a copy of the code up into the Analyst Hub. And so you can just grab that, hit copy code, go into, in this case, like if you, let's say you're starting a new file, you can either build that into your startup template, or you can just say get data blank query into the advanced editor, paste that code in, and then hit go. And what you'll have to do is enter some parameters in here, and then when you do that, it will create for you, and I'll jump back into the file we're using here. It'll create a dates table for you that has all the offsets built in. And let's just discard this, close this file down. Okay, so we're back to our original file. And as I was saying, the extended dates table has within it all of the offsets that you'll need. And then just type offsets. What you'll see here is it's got a day offset, a year offset, one for quarters, for months, ISO years, ISO quarters, a week offset, a fiscal year offset, and then there's a final offset that we're going to talk about later for net work days that Imke Feldman has put together that we use as an add-on function to this. So what you can do is through this dates table, you can move back and forth in time on any period. And what you can also do is it's got a series of columns that go along with the offsets, which are the is columns. So is it a working day? Is it a holiday? Is it a business day? Is it after today? So it dynamically adjusts so that we can look at present and past time separated from future time. We can look at the nature of days being holidays or business days or work days. And we'll look at all that in conjunction with offsets in a minute. But that's where the offsets come from. And if you go into the advanced editor for the extended dates table query, what you'll find is the way in which Melissa generates those offsets is very consistent. And that what she does is she finds a way to develop a numeric series that characterizes that series that you're looking at, be that quarters or years. And so in the case of quarters, it'll be the year integer and then the quarter number. And then from that numeric series, she'll normalize that into the standard offset format where the present period is 0, the next past period is -1, the next future period is +1, and so forth. And that methodology is used all throughout. And you can see that in the M code, and take a look at that if you are curious or even want to generate your own custom periods. So that's where offsets come from. And so let's close and apply that and go back to our previous period. And let's take a look first at how we would do this without offsets. So in this case, all we want to do is we've got 2019 through 2022, and we've got total sales, which is just a simple aggregate sum measure. And what we want to do is we want to find the total sales from the previous year. And Time Intelligence has a good function for that called date add. And when I mentioned before in the Pareto analysis that there was one function that the experts had identified as being in that top 20%, that was date add. And it's useful. I'm going to show you it's got some limitations. I don't particularly think it's necessary, but it's kind of one of those nice to haves. And basically what date add does is it takes and changes the context of your measure such that it moves forward or back a specified number of periods. And so in this case, it's taking our dates table, it's moving it back by 1 year. And this does exactly what you would expect it to do. So when we drop that in here, you'll see that it moves it back by 1 year. So what was 2019, 481,000 in total sales, now becomes 481,000 in 2020 is the previous year amount, and so forth. This corresponds to this in 2020, the 2022 corresponds to 2021, and so forth. So that does exactly what you think. But offsets has an equally easy way to do this. And so if we look at offsets, all we do here is we capture the selected value of the current offset, so the current year offset, and then we just save that as a variable, which is the current value of the offset minus 1, so 1 period back. And then we just filter the context of our dates table such that the offset is equal to the previous year's offset. And what that does is when we drop that in, that gives us, again, exactly what we would expect. And we just have to sort that by year in the same way. And it corresponds exactly to the date add measure. So nothing particularly special there. You might be looking saying, well, I'm not seeing the magic of offsets yet. So let's look at previous fiscal year. And in this case, I believe our fiscal year for the sample data starts in July. And so let's take our total sales previous fiscal year measure and drop that in. And this is the standard time intelligence. And you'll see we just get a shruggy because standard time intelligence can't handle fiscal years. The same thing would happen if we dropped it in with weeks, or we dropped it in with semesters, or we dropped it in with a 4-4-5 calendar. That anything that's outside the standard list of years, quarters, months, and days, DataEd can't handle. So let's see how Offsets does on this. So previous fiscal year. And you look at this and you'll see that this looks awfully familiar. This is the exact same measure that we had before, but instead of year offset, we've just changed to fiscal year offset. Exactly the same. And so if we drop that into our table here, we'll get exactly the right answer. And we can step over the shruggy from time intelligence, and we'll see that we're getting the previous year's total sales on a fiscal year basis. So that's pretty cool. So one of the things we can do that I think is really powerful is, given the consistency of the patterns that we see in offsets, we can automate these. And one of the coolest ways to automate DAX patterns is an external tool developed by Greg Deckler called Quick Measures Pro. And Quick Measures Pro is available only to Enterprise DNA subscribers, but Greg also has another program called Microsoft Hates Greg's Quick Measures. And there's a good story in that. And I've actually got an interview with Greg on video that, if you're interested in the full story behind that, it's quite entertaining. But that's available in his GitHub repository, and that's free to everybody. And it works very much the same way. The Enterprise DNA tool has some nice features, but if we go into external tools and we go to Quick Measures Pro, what you'll see that I've done is, in my custom quick measures, Greg has about 200 quick measures that you can just apply across any report here. And you can see that Greg has a similar view of the time intelligence measures as I do in his labeling of many of those. But if we go up to the custom measures, and these are the ones that I've put together recently and saved in my own file, one of them is previous period via offsets. And what we can do is, if we look at the DAX on this, or we look at the raw code, what we can do is we can templatize this measure in a way that is consistent within the Quick Measure Pro language, or specification. And Greg and I have both done extensive videos on this. We would highly recommend taking a look at this if you're interested in automating your measures. But one of the things we can do is, because of the consistency of pattern in the offsets, we can now take and we can select any of our offsets. So let's say in this case what we want to do is we want to do fiscal year offsets. Here we go, fiscal year offsets. So let's select that. And then for our measure, let's say instead of total sales, we want to do total profits. And so I've got a total profits measure here. We can just take this, select OK, and you can see the DAX then just updates automatically. We can create this measure, and it's previous period via offsets created successfully in key measures. What I should have done is I should have renamed this previous period, total profits previous period via offsets. And what we can do now is, without having to write any DAX, we can just take and drop that into our total profits by fiscal year. And you can see that it gives us the previous year's value of total profits without having to write any DAX whatsoever. And that's one of the things that Offsets lets you do because of the consistency in structure. So that's previous period. Let's move on to year to date. Okay, so now here we are in year to date. And year to date is related to cumulative sales. It's an interesting function, and I'll show you how it works and show you some of the power to it and some of the quirks. So if we look at year to date, that what it doesn't actually tell you much about what it's doing here. And so what we can do is we can just drop that in, and let's take a look at what it's actually doing. That what we've got here is we've got a matrix of year and month for the full span of our data. And in 2022, what we've actually got is we've got data for the full year. And so everything past August is forecast data, and before August is actual. And so if we go back up and we look at our data here, that what we'll see is the total sales in 2022, 557,000, and the year to date is 557,000, which means what year to date is doing is it's actually computing a resetting cumulative total, but it's not stopping at the current date. And I find that interesting and not to be what I had at all expected. So if we kick that into the visual down below, what we'll see is this cumulative pattern resetting each January, and we'll see it going all the way out in 2022. Now let's take a look at what our total sales year-to-date offset measure is doing. And again, this continues to follow the same pattern, that we get our selected value of the month offset. Then we've got our total sales. We've got our filter context change. So we're stripping the filters off of the offset and the is after today, so that we've only got the past and not the future. And then we've got the offset less than or equal to the selected offset, and that's what gives us the cumulative pattern in this measure. And the additional filter that is after today, which is one of the supplemental fields in the extended date table, that only looks at the present day and past values, we've got that set to false. So we're not looking at the future value in this case. So different from the year-to-date time intelligence function. And so what we do is when we drop that in, we'll see that difference show up in that last year. And if we drop this into our chart down here, we'll also see in that final year the divergence in how it handles the post current date. And let's change that to a different color just to make it easier to see. So here are year-to-date offsets. Let's change that to like a red color. Okay, and so now we can see that it's the same right up until the present date, in which case we've got more control with the offset measure, because what we can do is we can keep this in, or if we wanted to, we can comment it out. And if we comment it out, what we'll see is that line turns upward and becomes exactly equivalent to the year-to-date measure. So a nice feature of flexibility in there. What we can also do is we can take very easily, and if we remove the year context, but what we can do is we can turn this into, instead of a resetting cumulative function, we can just turn it into an overall cumulative function. So again, the offset gives us just a nice transparent view in terms of that predictable structure and a lot of customizability. So score 1 for the offsets. So now I want to jump into moving averages. And moving averages are another really common time intelligence pattern. And they're very helpful for discerning trends in highly variable data. So if we look here at our average total sales, it really bounces around pretty wildly over time. And so a moving average will kind of smooth that out and let us kind of see the trend in there. And this is one where I think offsets shine in a different way. They shine really in the area of simplicity. So if we take a look at like a 3-month moving average measure, this is pretty complicated. And I'm not gonna spend the time walking through this, but there's a lot going on here in terms of this, the last current date variable, the period, the dates in period, using that dates in period as a calculate modifier on our iterating average X measure, and just a whole lot going on here. And let's take a look and let's drop that measure into our table, and then we'll drop it in also to our visual here. We'll see how that kind of smooths out the trend line and lets us better see what's going on here. So we can see here that kind of smoothed out trend, and really see that in some sense there isn't a lot of trend in the data. But now let's take a look at the year-to-date offset, and I'm sorry, the 3-month moving average offset. And look at how much simpler that measure is. Like, look at the moving average standard time intelligence, and I look at the offset. All we're doing here for the moving average is we're taking a variable of our selected value of the month offset. We're then calculating our average sales, which is just a very simple aggregate measure of average sales. And then we're taking and changing the filter context such that the month offset is less than or equal to the current offset and greater than or equal to the current offset minus 3 plus 1, since it's including the endpoint here. So if we're in the current period, it's taking period 0, -1, and -2. If we're in the period before that, it's taking -1, -2, and -3 in the offset. And you can just see how simple that is in terms of it just calculating the average sale over that 3 offset period. And if we drop that into our table, you can confirm for yourself that it's producing exactly the same values in a much simpler way. And if we then take and we can again confirm that by dropping it into our visual, and you'll see the line overlaps exactly. And again, you get that divergence in terms of the last period in how it deals with the post August period. But up until that point, we can make those lines converge just in the same way we did before with the is after today variable or field. And so that is one where the simplicity of the offsets just shines. And so now let's take a look at our final case that we want to look at specifically, and that's going to be net work days. Okay, so the last specific case I want to take a look at is one that, again, is quite a common one, and we're looking at business days versus all days. And in this case, what we want to do is for every date, we want to compute the total sales from that date back to the last 60 business days. So let's say, we've got a business where we've got daily sales, but we only want to look at the pattern of weekday sales. We want to take the weekend days out. And so if we look at the standard time intelligence measure, this gets pretty complicated. What we've got here is we've got a virtual table that is doing an add columns of the total sales measure onto a filtered top end 60, and then taking that virtual table and running it through a SumX measure and returning the result. And so when we work through all that, what we get is, if we drop that into our table here, here's what we get in terms of our averages. And you can see, if we look here at a Friday, 69,964, and then 69,964, 69,964, and then it increments up again on Monday, because it's not incrementing for the Saturday and Sunday sales because of the filtering that we've done in the virtual table. Now there's another much simpler way to do this, and you're probably getting tired of me saying simpler with the offsets, but it's really true. And this one is simpler because of some really ingenious work that Imke Feldman has done on a really unique type of offset. And if we look at that, it's just in her blog, and it's also I've got it in the community section of the analyst hub in the M code. And here I've got the Imke Feldman net work days offset. And here's the code, and you can go to her blog and it'll walk you through exactly how to do this, and it's got the code in her GitHub repository. But I can show you exactly what it's doing, which, as I say, is really ingenious, in that what she's got is, and this is the one case in which offsets behave a little bit differently. So we've got this net work days offset. And remember how I said that the current period is always 0, and then the other periods go back by increments of -1 in the past or +1 in the future. Well, in this case, what she's got is if it's a regular weekday, it increments in exactly that way. But then if it hits a Saturday and Sunday, so you see Friday is -946, Saturday is -945, Sunday is -945, and Monday is -945. And then Tuesday increments back to 944, 943, and so on till you hit the next weekend. So basically, if we're going back 60 business periods, it's not incrementing for the weekend periods. And that's what allows the simplicity of this measure, which is our total sales, our 60-day sales for offsets. And what we've got here is, in this case, we've got just the selected value of the offset, the selected value of the date, and then we've got our filter context where we're saying the offset is less than or equal to the selected offset, and then greater than or equal to the selected offset minus 60, and then we've got the is business day equal to true, and the date less than or equal to the selected date, just because Saturday, Sunday, and Monday all have the same offset, so we need to set that additional filter so that it's not picking up the Saturday, Sunday. But the logic of this is, I think, much, much clearer than working through the logic of that. And so this, again, very, very closely follows the offset logic. And if we drop that into the table here, what you'll see is you can confirm for yourself that it produces the exact same results as the standard time intelligence measure. And this one has another advantage, and it leads me into my next topic of performance. And this is the last thing we're going to cover here, which is we haven't really talked about the performance of the standard time intelligence versus the offsets. And we want to see, how do those compare? And so if we go back to previous period, and what I've done here is I've used the performance analyzer, and then I've dropped the results into DAX Studio. And DAX Studio allows you to separate out the render milliseconds from the query milliseconds. And there's really not a lot you can do from a DAX standpoint on the render milliseconds. What we're really focused on for optimization in DAX is the query milliseconds. And you'll see for previous period, the two measures are identical from a query millisecond standpoint. So call this one a tie. The offsets renders slightly faster, but that's neither here nor there. So if we go to the year to date, we see a very similar pattern. Offsets rendering faster, but the query milliseconds being exactly the same. And then moving average, a tiny advantage to the offsets, but basically calling that one a tie as well. But if we go to business days, here's where we see a bit of a difference, and we see again the offsets, just because of the simplicity of the offset measure relative to the virtual table and the multiple iterators. Whenever you're talking about iterators, particularly iterators nested within iterators, that's a bit of a red flag for optimization. And so in this case, the offsets runs somewhat faster. But when you factor in the simplicity, the ease of automation, and then in some of these cases, the performance benefit, I think it really tips in favor of the offsets. And so that's really where I wanted to end. That I think hopefully that's given you kind of a whirlwind tour of offsets. And I think as you find that you experiment with your own measures and your own time intelligence, that it really will simplify things. And I think for me, it was really underscored in putting this presentation together, because it had been probably 2 or 3 years since I'd really worked through the standard time intelligence measures. And I was really struck by how much more difficult they were to put together than the offset measures. And so I think once you get used to that offset concept, I think you're really going to find that the offsets result in a significantly lower incidence of crying DAX. And so, if we go back to, Carlos's original meme, I think what we'll find is that offsets leave you much more at this point than at this point. And so I hope you found that useful. I hope that gives you something to experiment with and take away. And as always, thanks for watching, participating, and I hope you enjoy the rest of the summit.